So this is exercise 75 on page 23. In this exercise we are dealing with the following situation. You see here on the one hand we have here a parabola, let's call that parabola P, and here we have a triangle inscribed into that parabola, the triangle OPQ. And well, what do we want? We want the area of this triangle to be maximal. So the area of triangle OPQ should be maximal. Of course, this means that we are still dealing with optimization. Now, we know from the exercise, we know two important things. First of all, P is quadratic. That's given in the exercise. What does this mean? Well, the function equation of P is given by y equals a times x squared plus b times x plus c. The second important thing we know is that the triangle OPQ is isosceles. So these are the two things we know. And well, we will use this thing here later. We will start with this part here. And why are we going to start with this? Well, if you consider the situation, we need to find a way to express the area of this triangle somehow. And of course, in order to be able to do that, we need to know something about point P and about point Q. And this means we need the equation of the parabola. So this is of course something we will need. We need the equation of P, right? So let's see, what do we know about P? First, we know that it is quadratic. In addition, if you consider the exercise, we know here that this point lies on P, we know that this point lies on P, and moreover, we know that this point here lies also on P and has y coordinate 4.5. So we know in fact 3 points lying on P, so we can set up an equation of P. This is nothing to do with optimization. This is just finding the function equation. So we know that minus 3, 0, 0, 4.5, and 3, 0 lie on the graph. So we have 3 points lying on the graph, which means we can set up an equation system and find the equation of the parabola. So plugging the points into the function equation up there leads to so these are the three equations we get. Taking the calculator, we get y equals minus 0.5x squared plus 4.5. So this is the parabola. Okay, so now let us consider the triangle. Well, let us consider triangle OPQ. We want the area of that triangle to be maximal. So we need to find a way to express that area somehow. First thing, area of the triangle is given by G times H divided by 2. This here is G and this here is H. Okay, so this is the area. Now we can write this also like G divided by 2 times H. And now here is why it is important that the triangle is isosceles. This triangle here, since it is isosceles, is divided by H into 2 equal parts. So this means G is divided by the y-axis into 2 equal parts. So this here, just from here to here, that's precisely G divided by 2. And this here, of course, is H, like this. Okay? So the only thing we need is to find a way to express this line and this line somehow. Well, what are we doing? We introduce coordinates, of course. So let's say P has coordinates x and y. Okay, then next important thing, if P has coordinates x, y, then this line here is precisely x. So x equals this line here, and as explained just a few seconds ago, this is here, this is g divided by 2. Moreover, y is just here, right? So y is just the same as h. So y equals h. So our formula for the area is in fact given by x times y. And this is already my optimization equation. So the only thing I need is now I need a relation between x and y. So, and how can we get such a relation? Well, there's one thing we haven't used. So, in fact, the fact that P lies on the graph of P. So, P lies on the parabola. And I've used this step several times already. So this means the coordinates of P satisfy the function equation. So this means y is given by minus 0.5x squared plus 4.5. This is the second thing I need. Combining these two things leads to my equation. So plugging in y into the area formula leads to area is given by x times bracket minus 0.5x squared plus 4.5. And this is my function equation for the optimization. Okay, so what remains to be done? Well, just here I eliminate the bracket. So f of x equals minus 0.5 x to the power of 3 plus 4 times 5x. And now I'm basically done, because now I take the derivative of this and set it equal to 0. So f prime of x equals minus 1.5x squared plus 4.5. This is the derivative. I set it equal to 0, leads to x squared equals 3. X equals plus minus square root of 3. And of course here from the picture it is clear x is positive. So I can ignore the negative solution here. So x equals square root of 3. And this is it. So, well, what do we want? Well, we want to find the area of the triangle. So the area, we have already x, which is g divided by 2. So we need h. H is then given by plugging square root of 3 into this formula here, leads to h equals 3. So the area is given by 3 times square root of 3. And that's it. If you consider the exercise, well, we should also find the angles of the triangle. We are not going to do that. We stop here.